So as I was preparing to record this, I realized that some of this stuff that I'm talking about today probably should have been on last week's material, but I don't think it'll make a huge deal. So we're going to start talking a little bit about resistance training. Admittedly, this is not my area of expertise, so please let me know any and all the questions that you've got and any things that you wish that I would have covered, just so I know kind of how to move forward with this in the future. Last year, just due to a couple of things, we didn't actually go over this chapter. So this is only the second time I've covered this. So here goes nothing. So we've got just a couple of outcomes. They're pretty straightforward. So we're going to have some definitions, and then we're going to talk about how we can measure anaerobic capacity. And that's the part that probably should have gone last week when we were talking about anaerobic training. But when it comes to resistance training, this is training that's designed to increase strength, power, and muscular endurance. Okay, so this is a lot different than endurance training or aerobic training. So strength is just what's the ability of a muscle to generate force, and then power is the rate at which something can perform work. And for those of you that have had physics, you've probably learned that the equation for power is force times velocity. Oftentimes, this is measured in watts. Now, unlike, and I think I mentioned this last week, unlike aerobic training or aerobic capacity, it's really easy to measure that. And what I mean by that is that there is a gold standard. There's something that everybody agrees, like this is the way to measure aerobic capacity, and that's VO2 or VO2 max. However, when it comes to anaerobic capacity, there isn't a gold standard. And part of that is, well, what exactly are you trying to measure? Are you trying to measure peak power? Are you trying to measure average power, or something else? So there are three tests that have been used to measure aerobic capacity, but they're all different. And so we've got the Wingate, the critical power test, and the maximal accumulated oxygen deficit. So, there we go. So Wingate, I joke that this is the longest 30 seconds of your life. Okay, I swear that the 2 or 3 times that I've done this, that time has slowed down. I remember the very first time that I did this, I was a TA for exercise physiology lab at University of Oregon, and the way that they calculated Wingate was they actually had to count revolutions, and that's still true. But the nice thing is, if you haven't already done this in lab, when you do this, the computer does it for you. But we didn't have the Velotron at U of O. We had lots of other fun toys, but we didn't have that one, so they had to count it by hand. And so I'm demonstrating, and the students are counting, and then they're like, and I'm like, oh, I've got to be almost done. And then they start to say a word, and I'm like, oh, sweet. They're going to start counting down 3, 2, 1. And they're like, you're halfway done. I was like, you've got to be kidding me. And then to make matters worse, they lost count of how many revolutions. So I couldn't even figure out what my power output was. So anyway, with the Wingate, we can measure a couple things. We can measure your peak power, or we can measure your average power output over 30 seconds of the all-out activity, right? So you start out with essentially no weight, you ramp up, you're spinning as fast as you possibly can, and then they drop a predetermined amount of weight or resistance, and then you cycle for as long as you can for 30 seconds. It's terrible. Although you get into the debate of what would you rather do, Wingate or a VO2 max? The answer is a VO2 max. Then you've got the critical power test. And so this is, in theory, the maximum amount of power you can sustain for a long period of time. Okay, and when you read about it, it makes it sound like it's indefinite, but really it's 10, 15, 20 minutes. It's not forever. So if you notice here, we've got this graph, time, duration of exercise, probably better, power output on the y-axis. And so like for this particular person, they can sustain 700 watts, but it might only be for a minute and a half. Okay, whereas maybe they can sustain 350, 375 watts for 10, 15, 20 minutes. And so as they do these tests, they kind of figure out where this plateau is, where this nice flat line is. And so the lower the power, the longer you can sustain. And so where this plateau occurs, that's your critical power. And then last, you have the maximal accumulated oxygen deficit test. And this one is difficult to measure. Kind of the long story short, you do several different tests. You got to do a VO2 max test, and then you'll do an exercise test, at a submaximal exercise test and a supramaximal exercise test. And then basically you create a regression line. And what you're doing is during the supramaximal test, it'll say, hey, your VO2 is 50 liters a minute, but you should be using 52 or 55 or whatever liters a minute. The problem is because the power is so great, you can't take in enough oxygen due to whatever reason, things that we talked about last time. And so that difference, what you're using compared to what you should probably need to be using, is called the maximal accumulated oxygen deficit. And I'll actually show you a protocol of one in class. All right. Now, this one should be unsurprising, is correlated with levels of phosphocreatine as well as lactate. Those are things that are important to anaerobic activities. So, first lecture of resistance training, can you do these two things?